Hello everyone, today we're going to explore how our eyes work, why vision sometimes goes wrong, and the amazing ways light behaves. And don't worry, it won't be all theory. I'll show you how these ideas pop up in everyday life. Starting off with the question, how do our eyes work to create vision? It's a fascinating process. Light enters the eye through the cornea, an anterior chamber, passing through the pupil. The iris adjusts or dilates or constricts to control the amount of light that reaches the lens. The lens then focuses this light through the vitreous, a clear gel-like substance onto the retina. Here, the light energy is converted into electrical impulses, which are transmitted through the optic nerve, also known as the second cranial nerve. These impulses travel to the primary visual cortex, located in the occipital lobe of the back of the brain. And here's the amazing part. This entire process happens incredibly fast, taking around 13 milliseconds. Now, what happens when optics misbehaves? The following discussion will be about vision defects that many people in the world experiences. First off, we have myopia, or nearsightedness in our simple term. Myopia occurs when the eyeball is too long or the cornea is too curved, causing light to focus in front of the retina. This can be corrected by using concave lenses. Next is hyperopia, or farsightedness, to recall easily. So this occurs when the eyeball is too short or the cornea is too flat, causing light to focus behind the retina. This is often due to genetics or age-related changes. This can be corrected with convex lenses. So next we have astigmatism. This occurs when the cornea or lens isn't perfectly spherical, causing light to focus at two different points. So daghan kig focus ang iyahang light. This can be corrected, however, with cylindrical lenses. So now we have presbyopia. It's an age-related loss of near vision caused by the lens becoming less flexible and the ciliary muscles weakening. So the lens is reduced with elasticity, and ciliary muscle weakness make it harder to accommodate to focus on near objects. But fear not, this can be corrected with bifocals. So last, we have color blindness, although there are many more vision defects that's been experienced. Thus, we're sticking with the 5 most common ones. So color blindness is usually a genetic condition affecting the cone cells in the retina, making it harder to distinguish certain colors. And sadly, there are no universal cure for inherited color blindness. Now I guess it's time to talk about light itself. Firstly, we need to understand what polarization is. Polarization is a fundamental property of light waves that describes the orientation of their oscillations. In simple terms, polarization is the filtering of light waves. So i-filter niya ang light waves to make them vibrate in a specific direction. Imagine a rope that's vibrating up and down, and it creates a wave. This is similar to how light waves vibrate, but in multiple directions, up and down, side to side, and all angles in between. When light is polarized, it's like passing the rope through a narrow slit, allowing only waves vibrating in a specific direction to pass through. So kanang narrow slit, murag mao na siya dili siya ingon murag mao gyud. The narrow slit itself is the filterer gani sa light to make them vibrate in a more specific direction that you want. There are 3 types of polarization. First is the linear polarization. Sa linear polarization, ang light waves kay mo vibrate siya in a single plane, meaning up and down. Then we have the circular polarization, where the light waves vibrate in a circular motion, clockwise or counterclockwise. Then lastly, we have elliptical polarization, where light waves vibrate in an elliptical motion. So combination ni ang elliptical polarization sa linear o circular motion, as you can see sa picture. So how is polarization created? So first is reflection. When light is reflected off a surface, like for example water, glass, it becomes polarized. Then, ikaduha is scattering. When light passes through a medium, like atmosphere or particles, it becomes polarized. Then we have the polarizing filters. Mga special materials ni sila like Polaroid filters where they can polarize light, like for example, sunglasses. Now let's move on to thin film interference. So this occurs when light reflects off a thin layer of material, creating colorful patterns due to constructive and destructive interference. So kanagaling makita nimo nga color, different colors sa bubble when you blow bubbles. Mo na siya kanang ma-form in thin film interference. So when light hits a thin film, like a soap bubble, it reflects off the top and bottom surfaces, creating two reflected waves, or R1 and R2. These waves travel different distances, causing a phase difference between them. So as I said ganiha, the process kanang nag-involve ni siya light reflecting off the top tapos bottom surfaces of the thin film, creating a path difference nga nagdetermine whether the light waves interfere constructively or destructively. The conditions for thin film interference include a thin film thickness comparable to the wavelength of light, different kanang refractive indices of the film and surrounding media, and a coherent light source. Examples of thin film interference include soap bubbles, already exampled, oil slicks, then CDs or DVDs, and yes, butterfly wings. The phenomenon has practical applications in anti-reflection coatings, optical filters, and spectroscopy. To mathematically understand thin film interference, we have constructive and destructive interference, which are represented by the equations 2n 1t cos multiplied by theta equals m lambda, and 2n 1t cosine multiplied by theta equals m plus half of lambda respectively, where the n is the refractive index of the thin film, the t is the thickness of the thin film, then the m is the integer like 0, 1, 2, and the lambda is the wavelength of light. Last part of our discussion is Thomas Young's historic contribution to physics, waves, and optics. So, in the early 1800s, Thomas Young performed an experiment that showed light behaves like a wave. So what he did was he shone a light through two parallel slits, like, two tiny openings. The light passed through the slits and hit a screen behind. Instead of seeing two bright lines, he saw an interference pattern, which is a kind of a series of bright and dark lines. So why did this happen? The light passing through the two slits created two waves that overlapped. Where the waves met, they created bright spots known as constructive interference. Where the waves canceled each other out, they created dark spots or destructive interference.